On page 7 of your notes, you can find higher order derivatives. Basically, you will have to differentiate more than once. So just take note of the notation. If you differentiate once, it's just dy dx. If you have to differentiate one more time, then you raise it up to d2y dx squared, and so on and so forth. So let's take a look at this example now. Given this function y, if I differentiate once, power bring down 4 and 3 become 12, power reduced by 1, and so on and so forth. So if I differentiate it one more time, that will be d2y dx squared, meaning I will use this answer to differentiate again. So differentiate 12x cubed become 36x squared. Differentiate this become this. Differentiate 4 is 0. So now if I continue to differentiate this one more time, d2y dx squared will produce d3y dx cubed. So now I use this answer to differentiate further. Differentiate 36x squared, power bring down, become 72, power reduced by 1. Then differentiate number x is just a number. Continue to differentiate for one more time, that will be d4y dx4. So now I differentiate 72x will be 72. Differentiate number is 0. Now if you continue to differentiate this further, differentiate 72 is now just a constant, hence differentiate it is 0. And from here onwards, d6y dx6 or d7y dx7 and so on and so forth will always be 0. Now you just have to take note of other notations. The commonly used notations are these two. Okay, just take note that if you see a single prime, it means we differentiated once. If you see double prime, it means we differentiate twice. If you see triple prime, you differentiate 3 times. And from here on, you will not see any more prime. If we want to differentiate 4 times, we'll put the power 4 in a bracket. Note, it must be in a bracket. So further to that, if we now want to substitute a point, so if we want to find the first derivative where x is equal to 2, this means that first I differentiate once, then I substitute x is 2. Same for this, differentiate once, then substitute x is 2. This also means differentiate once, then substitute x is 2. On page 8 and 9, you will find implicit differentiation. Now, what is implicit differentiation? Let me illustrate. Suppose if you will have to differentiate x5, notice that I'm using the variable x here and the variable x here. So the variables match. So if I differentiate x5, it's just 5x4. But what happens if I have to differentiate with respect to x, y to the power of 5? Now the variables do not match. So here we will have to take care of the mismatch of the variables by chain rule. So if you look at what's written here, to differentiate y5, first you differentiate this like normal. So power bring down, power reduced by 1, you get 5y4. Then you have to take care to differentiate this variable with respect to x. That's why you get dy dx. So let's take a look at some more examples. In this example, I will have to differentiate y over x, and I'm going to do this by quotient rule. Okay, so take note, there's a mismatch of variable in x and y, but this actually matches. So let's start. Now keep the bottom, differentiate the top. If I differentiate y is actually 1, then now I have to take care of the fact that this variable does not match. So I differentiate y is dy dx. Then now I keep the top and I differentiate the bottom is a 1. So then divide by bottom square. Let me simplify this. This divide by this. And this divide by this. Now, let's illustrate with another example. This is more complicated because in the expression here, you will find three different variables, t, x, and y. And I'm differentiating with respect to t. So only this match, this does not match, and this does not match. So I will have to take care of it by chain rule later. Now first, I'm going to differentiate this part by product rule. So let's keep e to the power of minus t. Now I'm going to differentiate cosine 2x. Differentiate cosine 2x is negative sine 2x. Then differentiate 2x is 2. But remember, x does not match the variable t, so I have to take care of it. Differentiate x by chain rule. Next, now I got to keep cosine 2x and differentiate e minus t, which is minus e minus t. Now finally, differentiate y cubed is 3y squared. But again, remember the variable y does not match the variable t. So let's take care of it. Differentiate y by chain rule. So let me try to simplify this. Just neaten this up a little. Now, what is implicit differentiation used for? It's usually meant for this type of expression or this type of equation. If you can see, you have a y square here, you have a y cube here. It's very difficult to make y the subject of the formula like this. Okay, and hence it's very hard to differentiate using the normal method. So if you can't make y the subject, you will have to differentiate it in this form, and that is done. The only way is to use implicit differentiation. So the tip here, you will have to differentiate both sides. So let's try it for this example 9. I need to find the slope of the tangent, and slope means to find dy dx at this point, meaning when x is equal to 1, when y is equal to 1. But you're given this expression where you can't make y the subject of the formula, then how do you find dy dx? So this is where we have to differentiate implicitly. So I'm going to now differentiate both sides and differentiate the right hand side. Okay, so let's do this slowly. Now differentiate x squared is simply 2x. Differentiate xy, this you will have to do by product rule. So let's keep x, differentiate y, plus keep y, differentiate x is a 1. Now differentiate y squared is 2y, but take note the variable does not match, so by chain rule differentiate y. Finally, differentiate 3 is 0, so I'm done on the left. And on the right, differentiate 0 is simply 0. So remember, you want to find dy dx, and you have dy dx here as well as here. Now these two terms does not have dy dx, so you will want to bring over to the other side. So on this side, you will have negative 2x and negative y. And on the left hand side, I'm going to common factor dy dx. I'll be left with an x as well as a 2y. So now I can make dy dx the subject of the formula and divide this over. I'll have minus 2x minus y over x plus 2y. Finally, I will have to sub this point. So at 1, 1, dy dx is minus 2 minus 1 over 1 plus 2, which is negative 1.